In this video, I'd like to continue talking about geometric series, specifically looking at a finite geometric series. And to handle a series that is finite, we'll use a lot of the same techniques we use with infinite series, but with a few subtle differences. So to start this, we'll approach it the same way. We need to find the common ratio. And remember, the common ratio is just the number that we multiply by to go from one term to the next. And this one, it might be obvious to see that you're multiplying by 3 every step of the way. But remember, if you're not sure, you can always take one term in the series and divide it by the term before that. So 18 divided by 6 gives us 3. And you can see that 2 times 3 is 6, 6 times 3 is 18, or even at the end, this 13,122 multiplied by 3 does give us our last term here. So at this point, we are looking to add up this series. So let's call it some letter. We'll call it S for sum. And we'll use the same trick we use when evaluating infinite geometric series. So we're going to multiply the entire sum by whatever the common ratio is. So we'll multiply S by 3, and essentially the 3 will distribute to every term here. So we'll get 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and so on. And when we look at the end here, this 13,122 multiplied by 3 gives us 39,366. And when we multiply 39,366 by 3, we get 118,098. So from here, we're going to take our original sum here, this original geometric series, and we're going to subtract the new one that we created. So we're going to take, let me make a little bit more space. We're going to take, S, and subtract 3S from that. And by doing so, we'll be able to notice a pattern. We'll be able to make a lot of cancellations. So for starters, notice this original series has the value of 2, but there is no like term in this new one that we created. So 2 will remain, but then we have 6 up here, and we're subtracting 6 down below. We have 18 here, and we're subtracting 18, so those will cancel. That's equal to 0. We'd have 54 minus 54, and so on. And this 13,122 would cancel with the term before this in this series, so that would cancel out. And 39,366, we're subtracting that same number from itself, so that will cancel. But notice, in this case, which we didn't see when we had infinite geometric series, there is one term left over at the end. So we are subtracting this term, so it's minus 118,098. And you'll see this makes sense that we have a negative here since S minus 3S simplifies to negative 2S. And 2 minus this number would be negative 118,096. And then from here, we just need to solve for S. So let's divide everything by negative 2. And our final sum will be 59,048. So this is our answer to our finite geometric sum here. And notice one major difference when adding up these finite sums compared to infinite sums is that in this case, our common ratio, which we can call R, it can be bigger than 1. That's possible. It can be a fraction or it can be a negative as well. But since we're adding up only a finite number of terms, R can in this case be anything we want it to be. Whereas with the infinite geometric series, R always had to be a fraction. It could be a negative fraction or a positive one, but it had to be a fraction since in that case you actually are adding up an infinite amount of terms. So if the terms keep getting bigger and bigger, then you're adding up bigger and bigger numbers, and we'd say the series would diverge. It would approach infinity as the term number approaches infinity.